Okay, now I can get the right stream up. Seems to be not visible. You guys see a black screen, or can you see something? Okay, that's not good. Let's see.
Showing like a Chrome tab.
Now you see it? Okay.
Yeah, I can see it now.
It zoomed in. Yeah, this is weird because it doesn't show me anything on my end. Yeah, that's. Okay, so right now, does somebody type out or say, what do you guys see on the screen?
Black screen.
Still black. Okay, well, this looks like it's a this looks like it's a Discord issue. So let's stop it and then start it up again. Yeah, that's probably the best idea. Yeah, let me try that. Okay. All right, you guys can see that?
Yeah.
Great. Okay, perfect. So, let's see. Is Sergio, are you recording now? Okay, perfect. So we'll get started then. All right. So first of all, there is an assignment up here on Memer. And just for fun, let's see how many people have already finished it. So a lot of people have already finished it. You see quite a few people have gotten 100%. And it's not a terribly difficult assignment. So let's read through it. First, you are going to ask the user for their first name. Store their name in a string variable. You decide on the variable name. If their name is longer than 8 letters, tell them they have a long first name. Otherwise, say nothing. All the prompts for the program must match the prompts below. Then, ask the user for their age. Store their age in an int variable. If they're 18 or over, tell them they are an adult. Otherwise, tell them they are children. Then ask the user for 3 hobbies. Store each of the hobbies in their own variables. Hobbies may need more than one line to store. If any of the hobbies is running, tell the user that they have a healthy hobby. Lastly, thank the user for using the program. All output shown below. Okay, so what are some things that are going wrong with this straightforward assignment? Well, one thing is people are sending me messages saying it doesn't work, and they're using different capitalization in the prompts. So they might write, enter your first name, all lowercase. They don't have the E capitalized. And that's not a huge deal in terms of like a person could understand that you mean the same thing, but Memer is going to just mark everything wrong. So it's very important that you follow this spelling in these prompts, okay? The other thing is when you're reading in data, you might come to a point where you have an enter hanging out in the buffer. So let's say that you type out the age, 18, and then you press enter, and then for the hobby, you have a get line. Well, the enter from the enter age is going to go into enter hobby. So what we use for that is we use something called cn.ignore. And cn.ignore will skip the enter in the buffer. For instance, that's one use of it. And I think that if you pay attention and just think about the spelling, you'll be able to get it done in not too much time because it's not a terribly complicated idea. You're just asking for some data and then giving an output, give an output depending on what they entered, right? Like if they're 18, legally they're different than if they're 17. So you just have to check if age greater than or equal to 18, you say welcome to adulthood. Or let's find a child. For age 7, you say childhood is an amazing time. Okay? With the exclamation point, and you get multiple attempts to turn it in, so it's not like it's a terribly difficult thing to do, but you do have to abide by this due date. So the due date, 6/26 at 11:56, means you got to do it at some point over the next few days, right? Yeah, exactly. If you leave a period off, it won't accept it. So maybe at some point, Memer will add in like sentiment analysis or something. I don't know, like, oh, this is what you meant. But I like the fact that it is that specific because you have to really abide right now with that by the way computer programming is. So like if you leave a semicolon off your C++ program, then it won't mark it right. So I think it's actually pretty good training for learning how to program. And I like that. I like that it's so specific. I think that's a good thing. All right, so the next thing we'll take a look at is we'll take a look at Freer School. So we have two things going on concurrently at the same time. So if we go to Intro to C++ and we go down to today's date, we can see that there's a Chapter 3 quiz that's open. And see, the questions are going to be all about the C in, C out, Chapter 3. It's really straightforward stuff. The manipulator used to establish a field width for the value immediately following it. Okay, so did we see field width? Did we see set field? Did we see IO manip? Did we see set W? It's just a matter of going into chapter 3, looking it over, and just basically it should be an easy A. You're just finding the right answers. The issue is some people are forgetting to do these. And well, okay, so I see Jose comments, Memer does tell you what you got wrong. Yes, it does, but I guess what I was saying, or the point I was trying to make, was if somebody leaves off a comma, most people will be able to like understand the meaning and they can say, oh, all right, I understand what you're meaning, and then maybe like grade on a curve. But Memer doesn't do that. Memer just says, oh, you left the comma off, you get a 0 on this test. So you sort of have to approach the problem not like you would in another class where your English teacher might give you an A minus if you leave your commas off, but Memer is going to give you a really bad grade. All the tests that require commas, Memer is just going to everything else you did won't count. So it's like an all or nothing thing with these IO tests with Memer. But that's the good thing. It'll even tell you the line number. So even the line number on Memer. Now sometimes like there's the option I could turn off the the feedback from Memer, so you would just see wrong and you wouldn't see why it's wrong. But I think that's like a level of um, discomfort that most people don't need to deal with right now. So yeah, you do get to see the line number that's wrong. You can fix it and then resubmit it, and then hopefully you'll learn from it. But yeah, these quizzes, they are important to pay attention to. The Memer projects are important to pay attention to. We're going to do lots and lots throughout the summer, but if you start missing them, then you're going to be in bad shape because the zeros will start adding up, adding up, adding up. So you want to try to stay on top of your grades, do as well as possible, and it's just not a workable solution to expect like in the last week of class that I can go back and reopen everything. So you got to do everything as we go through the semester, and it's not the course is not structured so you can just do it all in one day. That's not possible. You have to do it over time because it's going to build on each other. So you can't just do it all in 1 week or 1 day or whatever at the end. Okay, so let's go ahead and look at the syllabus for today. And we see that 623, we're going to be looking at making decisions. I just told you that there's the quiz up on Freer School. So we're going to go over textbook 4.7 through 4.15. So let's pull that up. Okay. So flags. A flag is a variable that signals a condition. Usually this is implemented as a Bool variable. It can also be an integer. So 0 would be false. Anything else is considered true. So why would you have a flag? Well, you might have a flag if a button was clicked, if you found a true statement, if it can be used in many, many different scenarios. Flags are just programmer defined. So whatever problem you're working on, if you want to keep track of a certain condition being met, you can just make a Bool variable and then save it for later when you want to have your output, want to save the data, want to write it to a website, whatever. Like whatever you need to do with it, no problem. You've got your flag holding on to that condition. As with other variables and functions, it must be assigned an initial value before it is used. Okay, logical operators. These are really important. So these are used to create relational expressions from other relational expressions. So you can have and, you see you have the two ampersands, and this is a new relational expression is true if both expressions are true. So it has to be the left and the right. Both have to be true for the and to be true. Or is a new relational expression that it's true if either expression is true. So what's on the left or what's on the right. Not reverses the value of an expression. So true becomes false and false becomes true. So this is logical not when you see the exclamation point. So we have and is like this, or is like this, and not is like this. So the pipes you can find beneath the backspace, I guess, unless you have some custom keyboard. The ampersand is number 7, shift and 7, and then the exclamation point is shift and number 1. and or not? Yes, for sure. Yeah, yeah, that's a good question. So you can have them chained. Discrete math. Yeah, that's great. I'm glad you noticed that. So discrete math and programming, they definitely go hand in hand. I mean, initially programming was really thought of like as applied math because when it comes down to it, this is what computers understand. The circuits are going to evaluate things to yes, there is a current there, no, there's no current. Current is on, it's true, current is off, it's false. And so you're taking this underlying hardware and we're writing code that works on it. And this is just like a really, really key concept to manipulating our data and making our programs work. So let's see some examples here. We've got int x, x equals 12, and then int y, y equals 5, and int z, z equals -4. So we have x greater than y. Is that true or false? Well, 12 is greater than 5, so that's true. And so both sides have to be true. Y is greater than z. Well, 5 is greater than -4, so both are true. So the whole line evaluates to true. And then we can see x is greater than y. Well, we just agreed that 12 is greater than 5, so that's good. And then we see -4 is greater than 5. And no, -4 is not greater than 5. That's false. So because one side of the and is false, the entire line is false. All right, so these are informative. So let's do all of them. 12 less than or equal to -4. No, that's false. So if that was an and, we would immediately, we know that's false. But it's an or. So then we can look on the other side and we see, is 5 equal to -4? Well, that's false also. 5 is not equal to -4. So neither is true, so the or is false. One has to be true for or. One side must be true for or, and then both sides must be true for and. All right, so this is good. Then we look at the next one. Is 12 less than or equal to -4? No. Or 5 is not equal to -4. Yes, that's true, because it's not equal. So we have a question here. It says, can you have a variable change with certain inputs so that when you input data from the user into the program, the statements change from being true or false and or false? So you mean if you have the user see in the values for X, Y, and Z, and then later the program will determine based on what the user entered in? Yeah, yeah. The input value that changes the value of Z, Y, or X, for sure, you don't have to. Yeah, that's a good question. You don't have to just hard code a literal like we see on this example here. You could change the value based on a user entering it in or reading it from a file. So it really, this doesn't require typing in something like C++ int x equals 12. That's not a requirement, not required. You could read it in, the value of x could be read in from the console or a file. And I'm not sure, maybe that's not what you're asking. I see you're typing now.
I was just explaining with words, I guess. So,
Yeah, yeah,
what
yeah.
I was kind of asking was, can you make a sort of dynamic program that, based on what the user inputs, the value of z may not be -4, it may be like 6, and in that case, 6 would be greater than 5, so it would return true instead of false.
Oh yeah, that's what I thought you were asking. And the short answer, yes, it can't. You can. All right, cool. So then we look at the last one, and we see x is greater than or equal to z. So, all right, 12 is greater than or equal to z, so that's true, but look at the exclamation point. The exclamation point reverses it, so you go from true to false. So the point of the exclamation point is logical not reverses the, let's say, how should I put this? Reverses true into false, or false into true. All right, so let's continue on here. And we can see an example. It's a negation. Yeah, that's a good way to put it. It's a negation. So if you're employed and you're a recent grad, you qualify for the special interest rate. Both have to be true. So instead of using nested ifs, we can use the and. Very, very useful to use and. All right, here's one. If your income is greater than or equal to the minimum income, or your years are greater than the min years, either one, they say you qualify. You can add logical not if you want to write the logic that way. That's possible too. So we're saying if you're not, if your income is not greater than or equal to the min income, or your years are not greater than the min years, well, those are the qualifications. All right, so not has the highest precedence, followed by and then or. If the value of an expression can be determined by evaluating just the sub-expression on the left side, then the sub-expression on the right side will not be evaluated. So let's think about this. If you have an and the left side of the and is false, why run the right side? And it won't. That's what short circuit evaluation is. So it just saves a teeny tiny bit of time in your program, nanoseconds, but if you're dealing with lots and lots of data, maybe it'll be noticeable to a human being, right? When you're dealing with big data, then it's important. Checking numeric ranges with logical operators. Okay, so you can see if a value falls inside a range, outside a range, but this is the most important part of the slide. You can't use mathematical notation with C++. So this, if 0 is less than or equal to grade, less than or equal to 100, this doesn't work, no. But this will work with Python. So I'll say no with C++, but yes with Python. Just to let you know and remind you that different languages implement their syntax differently, and there you go. Okay. Menus. We're going to spend a lot of time with menus today, writing menus, practicing with menus, and I think it's going to be really useful. So menu-driven programs are programs where the user controls the actions from selecting from a list of actions. All right. So you give the user a choice. Press A to see your grades. Press B to see how many credits you've taken. Press C to do this. Press D to do that. And then you read it in. You give them what they want based on what they typed. So you could implement them using if, else if. Usually you use numbers or letters to drive the menu program, and you prompt the user to make the selection, and then you test the user selection in the expression. If there's a match, you execute the code for that action. If not, you go on to the next expression. Okay, so why don't we go ahead and start doing some menus here? We'll do the first menu with if statements, and then later we're going to go on to do to menus with switches. So we'll start first with a menu program with if statements. Let's go ahead and say a new REPL in C++. And it's kind of funny, from last night till now, it looks like Replit has changed their user interface a little bit. Or maybe it just didn't load properly. I'm not quite sure. All right, so why don't we go ahead and make this a student application, and I'll just copy and paste the link to my REPL if you wanted to just follow along that way. So instead of hello world, let's have on the top student records. And now we're going to give just 3 different options for students to view. Okay, so the first option is going to be view your grades. And then we're going to give them the option to view your advisor. And then we're going to give them just one more thing. What's one more thing a student might want to have with student records? Okay, credit history. All right, credit history, that's good. Okay, so maybe just to differentiate things, we'll say view your grades from previous semester. So this time we'll use if statements. So let's start with the prompts. We can say here, std cout, enter 1 to view your grades from the previous semester. We'll have a \n, and then we can have it all in one line, but we'll just do it like this. Enter 2 to view your advisor's information. And then we can write out enter 3 to view your credit history. Okay, so now what we're going to do is we're going to have a variable to store their choice. So we can say int user choice, and then we can just read it in with cin. So we can say std cin user choice. And now we're just going to make some dummy data just to prove that this program will work. So we can say if user choice equals 1, then we'll just print out cout calculus B, comma, C++ programming A, comma, I don't know, they took 3 classes, chemistry A. Okay, end line. So that's if user choice is 1. Then we can say else if user choice, we're not really using and or not here, but maybe we can think of a use for that. Else if user choice equals 2, then we can say STD, C out. We'll do an example with and, or not next time. But for now, we can say the advisor's name is George Jetson, and G Jetson at mdc.edu. Okay, so now we're showing the advisor based on pressing 2. And then the other option is going to be view the credit history. And we can say user choice equals 3. And we can just print out here history, world history, 3 credits. We'll just do 2 more. Then they took karate for some reason, they got 1 credit, and they took marine biology, and they got 4 credits. Okay, so now we can have an else, and the else is going to say invalid choice. So later on today, we're going to learn how to use switch statements. Switch statements are usually used for menus, but this is just showing you that you can use if statements. So let's test it. And we can say, all right, we want to view the grades. So we see the student got a B in calculus, an A in programming, and an A in chemistry. So it's a pretty good student. And then we can go ahead and run it again. We can see 2 gets us the advisor's info. And then if we run it again, well, we'll run it 2 more times. We can see the credit history. And maybe logically, we should also put the grades from the previous semester. But, you know, there's only so much detail that we need to add to this example, but I'll add it in, why not? So then we can say calculus is a 4-credit class, C++ is a 4-credit class, and chemistry is a 4-credit. Well, I guess chemistry is divided up with the lab, and so whatever, we'll just put 3. All right, question.
What if you put the number 4 in? Would that activate the invalid choice?
Yeah, let's try that out. So it should. So if we rerun it and we press 4, we see, yeah, invalid choice. Or even if we do, let's say like -1, yep, invalid choice. So that's a really good question. And let me go ahead and post this inside here, C++. So now you can see this is a menu-driven system using if and else if. So let's see other questions in here. Is it possible to keep running the answers? Yes. So this is something called a loop. And a loop is a really important part of programming. So I think a lot of times when you're teaching a course like this, I really like the question, and I'll show you how we can do a loop here so it just keeps going forever. Sometimes I say, oh no, that's not for this chapter, we won't do it. But it's such an important point. Let's just go ahead and put everything in the loop. So we're just going to type while true. And this program will basically never end. It's never going to stop running until they turn the computer off. So let me show you. Okay. So now if I run it, it'll say 1, view your grades, 2, view your advisor, 3, view your credit history, 4, incorrect. There's no way to leave this. So the program will just keep doing this. You can imagine we've got a computer sitting outside when we return back to MDC, and it's just sitting running on the console and just waiting for students to come in. Now, this right here is not a good program yet because we haven't asked for a particular student yet. That would make this a really interesting program. And by the end of this course, we'll be able to do something like that, where we have student records stored, the student will type their name in, we can call up their records, and then show just their information so they can like log in and log out. And that's not terribly difficult. Like that's something we could do by the end of the semester. But for right now, this will just show it keeps running again and again. And that's just because we're saying while true. And then we're never breaking out of the loop. So that's a good way to just introduce loops. And now you'll see your first loop. And this is how games work. Games have a game loop where the game loop keeps running, and as long as the game is going, it's going to keep changing output on the screen and, you know, just making the game look like things are happening when it's just really about moving pixels. It's about moving pixels just to make it seem like, well, that, you know, Pac-Man is eating ghosts and things like that. So we could end this loop. Why don't we say here, if they pick an invalid choice, we'll break out. So if we wanted to break out, if they do an invalid choice, we just add the word break in. So we could say 1, 2, 5, and it breaks. So the key thing to making it work with an invalid choice is we just add the word break. Break will do it. All right, so let's go ahead and continue on with the presentation. And then we'll get you guys doing some examples, and we'll do an and, or, and not example a little bit later, but we'll cover a few more slides. So validating user input. So input validation is when you inspect input data to determine whether it is acceptable. Bad output will be produced from bad input. So garbage in, garbage out. You can perform various tests. You can have a test for range, reasonableness, valid menu choices, divide by 0. So here we have a test score app or program, we'll say. Usually you think of app with like a cell phone. So we ask the user for a test score. If the test score is greater than the minimum score or equal to the minimum score and less than or equal to the max score, then determine their letter grade. Otherwise, tell them an invalid score was entered. Comparing characters and strings. Characters are compared using their ASCII values. So let's go ahead and look up ASCII table. And let's copy this and paste this. And somebody click on that link and tell me what's the value of t as an int. So look up t on that table. Capital T is what int value in ASCII? Good. Somebody found 84. So if you look on this slide, we see the ASCII value of A is 65. If you can do that sort of math in your head, that's awesome. Like what's the distance between T and A, and then what's the distance in positions in terms of how much do you add to 65, right? So we can do the math. 84. It's a lot easier if you know it's 84. Then you just do 84, 65. But the point is, with all this babbling I'm doing, is that characters are treated as numbers by computers. That's the whole point. That we look at letters as distinct, and you learn them very young about, oh, this is an A, this is a B. It means something to you. It has a value for you, but there's none of that attachment that a computer has to A. To computer, it just treats capital A as 65. A is 65. Because remember, what are we going for with all these computer programs? In the end, we have to reduce everything to zeros and one. Zeros and ones. That's the end goal of everything, because computers are designed that way. All right, so lowercase letters have higher ASCII codes than uppercase letters, so lowercase a is greater than capital Z. Okay, so we can have a program where we ask the user for a digit or a letter, and we can determine if the user entered a number, right, a digit, or an uppercase letter, or a lowercase letter, or that is not a digit or a letter. And you notice with this program, we do have the and being used. So this looks like a good example. We could give this a try. So let's go ahead and make a new REPL. Oh, now this is what I was expecting. So no, they didn't change their user interface. It just didn't load the same last time. Can you? Yes, you can. You can, because you can cast. You can cast it. That's a great question. Let's go ahead and play with that. So we'll say casting and working with characters. Okay, so I love this. Let's do this. So we'll first start with the while true. So it's a good idea that we'll get everybody used to working with loops. So this way we can keep running the program again and again and again, reading in characters and playing with them. So let's first start with asking for an int. So we'll say enter a whole number from 0 to 256. And then we're going to say int user choice, and we'll just read it in with the cn. So we can say here cn, we'll just separate it, std cn into user choice. All right. And now, can you save a character as an int then? Yeah. So what we want to do is we want to display this as a character. So we're going to print out cout char user choice. So notice how I'm casting it with the C style cast. And let's run it, make sure it works, that I'm not leaving something out. Okay, so before we said 65 was capital A, so we type 65, and then we'll try 84 to double check on what Jose looked up, right? That's good. And then we can try 232. Oh, okay, that's interesting. 231, 230. All right, so I don't think that these are visible for some reason with, let's go to the ASCII table. Let's find out what those numbers are. So, you know what? I think I'm going too far. So if I look here at the decimal, I thought, wow, I thought there were more ASCII values, but it looks like, yeah, it's okay. So extended ASCII codes, I guess the extended ASCII codes are not enabled for Replit. So let's try to make these numbers smaller. Let's go to, because I was thinking they were up to 255. All right, so let's see here. Let's go to 127. So we say 127, okay, 126, 125, 124. All right, so now we're getting some reasonable things. So one thing I've got to change is 0 to 127, because it looks like anything past that isn't showing up on REPL. So the extended ASCII codes don't work. But that should work. That will give you a program to view characters based on what the user types in. And I think, Jose, just to show you, like in practice, we can have a char C equals user choice, and then just print out the C. Then we can do the casting outside, and it'll work. Yeah, it is. It is pretty cool because it really makes you think about how computers deal with all the text that we enter in and how the integers eventually are going to be turned into binary, and that's really what they deal with. So I see Roger typing something out, so I'm just going to sort of wait a second. Okay, does it matter in this example that you're not asking the user for input? Okay, that's a great question. So really the whole point of those prompts is just to help the user. If you wrote the program for yourself and you know that you're expected to type in a whole number, then you just run the program and type in the whole number. Now, the issue would really be what happens in a month when you run the program if you're not looking at the source code? Well, it's not smart to have no prompt because you're probably going to forget what you were doing. So yeah, it's better to have a prompt. I think sometimes when we're just working during the constraints of class time, we only have from 10:20 until 12:30. I'll probably just do examples where we don't have a prompt, but it wouldn't really matter to the compiler, to the running of the program. So we could probably just add in what I have in my comment, and I think that would be a good solution. All right, and then we see another one that says, where it says while true, what's true in this case? Why does it keep looping? Well, what's true is the value of true. So true in C++ is the same as 1. So if I was to replace the word true with the number 1 and rerun it, okay, 0, 1, 2, 3, 4, 5, 66. Well, a lot of the early ones have nothing. That's interesting. So yeah, it's just basically true equals 1, and that means that this will always run. Yeah, so like if I was to say something like 5 is greater than 4, that would work also, because 5 will always be greater than 4. So I could say 64, 67, I don't know. So well, the return 0 is that's just being added in. That's just being added in by the compiler. Compiler is adding this. I mean, let's look that up. So C++ return 0 added in. Let's see. Do, 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 do. All right. Let's see. Yeah, this is the best answer. So if you Google and go to solo learn, some compilers will insert it at the end of your main function if you forget, but not all will. Either way, it is needed for your program to run correctly. So if this return 0 didn't get added in, like we were using a compiler, well, basically, there's no way in this case, without us stopping the program, to get to return 0, because we will never break out of this loop. This loop is called an infinite loop. So I think I see now what you were getting at. An infinite loop will never stop. So we're in an infinite loop here. 5 is always greater than 4. 5 will never be less than 4. So it just won't break out. So I guess this is the danger of like starting new things like loops. But loops are so important. This is definitely not a waste of time. So this is a very worthwhile conversation. And then when we get to more examples with loops, when we get, a little bit further on, then it'll be helpful that we've talked about this. If I was to say, while 5 is less than 4, how many times will this loop run? Somebody take a guess. Yeah, it'll never run. So we run the program. Yeah, now we get the return 0. So if you have some kind of condition that's false, then you get the return 0. Now this is not an infinite loop. Now this is just a loop that never runs. So 5 less than 4? No, impossible. Okay, very good. All right, so comparing string objects, we have string name 1 Mary, string name 2 Mark. Is name 1 greater than name 2? Yes. Is name 1 less than or equal to name 2? False. Is name 1 not equal to name 2? Yes, that's true. And why? Because character by character, the comparisons are made with the strings. And we see that the ASCII value is what matters in determining they're greater than or less than or equal to. All right, so here we see determine and display the correct price. So we've got if part num equals S-29A, then the price is so much. Otherwise, the part is S29B. And this is the example of business programming that is just so common and so important to just the capitalist world that we inhabit, right, in America. So companies have lots of inventory. Companies have lots of, data to keep track of, and they need a lot of programmers. So that programming is necessary in non-capitalist endeavors. Like someone could be a hater of capitalism and make a video game and just release it for free and not charge any money, right? It's not like there's any connection. I'm just saying if you look at Indeed.com and you look at all the jobs that are available, especially in South Florida, many of them are corporations, for-profit companies that just need to digitize records. They need to keep track of basically what's going on with their company. So let's go ahead and prove this. Let's go to Indeed.com and let's type out C++ here in Miami and see if most jobs are, okay, C++. All right, let me try that again, C++ in Miami. So we see there are 55 jobs that have C++ in Miami, and we've got a Windows developer with, what does this Verazzo do? Has anyone ever heard of Verazzo as a company? Anybody? Well, this developer is going to do front-end application design and development, just sort of to talk about, well, yeah, with offices still not 100% open, a lot of remote jobs are going to be available, and they're urgently hiring. I'm kind of curious to see what this company does, because I keep talking about profits. And let's see. It is a California corporation. Oh, wait, no, they also have one here in West Hollywood. Okay, so they are a local. No, they're headquartered in. Okay, so that's really funny. Just thinking about like geography. So Santa Monica is a city in California, but they're in West Hollywood, Florida, and Hollywood's a city in California. So it's, I don't know. I think that's kind of funny. But yeah, this is a corporation. Can't quite see what they do based on this, and I don't want to spend too much time focusing on this. But anyways, point is, if you learn C++ and you want to earn between 60 and 90,000 a year, you can apply to them. So that's kind of interesting. And then we can see there's PavCon. If you see LLC, wow, this is a really high-paying remote job, up to 240,000 a year. Wow, up to $250,000 a year. That's pretty good. Probably have to have a lot of experience to get that one. But you just go through and I think it's important that you sort of just think about the skills that you're learning in college and see, is it anything related to the job market, right? Now that shouldn't drive your whole life. If you really can't stand programming by the end of this course, maybe try another course, see if you like it more. But it's not going to become more fun as the years go on, I don't think, because programming is, well, there's kind of a stereotype that younger people are better at it than older people, and so you're at an advantage if you're younger. That's not really like, it's not really like a controversial thing I'm saying here. But jobs with Java are more plentiful than C++, okay, in South Florida. So I've been teaching Java a long time. I've been teaching C++ a long time, but I'm leaving Indeed right now. Maybe I'll visit it again at some point in the future. Maybe I visited it in the past, but I just wanted to show that there are developer jobs here in Miami. There are lots of remote jobs now, and certainly the skills you're learning are relevant. Okay, let's close that, and let's go back to here. And now we've got the conditional operator. Okay, the conditional operator, sometimes called the ternary operator, this is used to create short if-else statements. It works like this. True runs, whatever is after the question mark will be displayed. Otherwise, whatever is after the colon will be displayed. So something like this. So let's go ahead and go back to Replit and say new REPL. C++. Let's call this conditional operator C++. Okay, so we're going to have the user enter in the data. So we'll say enter two enter two whole numbers. And then we're just going to make int I and int j. Then we'll say cin into I, cin into j. And now we are going to print out the value of, we're just going to say which is larger. How about that? So we're going to do it within one print statement. We'll say cout. If I is greater than j, then we are going to return I, well, we'll just say the first number is larger. And then we're going to put after the colon, the second number is larger. And one thing we're going to put inside of this prompt is we're going to say that two numbers must be different. So they can't enter in the same number. And actually, maybe we can use the loop to require them to make the numbers different. So that might be kind of fun. So let's try to run this and see if they abide by the rules, will this work? So let's copy this code into, well, let me run it before I copy it, because it might not work. So we see two numbers, we have 10 and 9, although I think it will work. And we see the first number is larger. So now let's try to make the second number larger. So we say 9 and 10. Yes, the second number is larger. Good. So now I can be confident after I tested it in posting this into Discord. Okay. And I could also post this conditional operator link. Okay. So what's happening here? We're doing some sort of comparison. We've got I is greater than j. If that's true, then what runs after the quotation, what runs after the question mark is this string. The first number is larger. Okay, if j is larger than I, then the second number is larger. So let's do something fun. Let's have a while loop where if the numbers are the same, we'll keep prompting them to enter in different numbers. So we're going to say while I equals j, keep prompting this and keep entering this. Okay, so I'm going to say 9 and 9, 8 and 8, 7 and 7. The only way we can break out of that is if we do the proper numbers, where they're not the same. So here's sort of a practical example of how we can use a while loop to ensure that the data is what we are expecting, that the two numbers are not the same. Yes. Okay, so I see what you're saying. You're getting at this. You're getting at the fact that we can go ahead and set these two to be both equal to 0. You want to save some code. I like the way you're thinking. And we can now just have this one while loop. Okay, so let's try that. So we can say enter two numbers, 8 and 8, no, 7 and 5. Yes, this will work. And I really like how you zeroed in on that. The fact that I had repeated code, and that's not very efficient. Like if you find yourself copying and pasting lots of code throughout your program, it's not very good. And yeah, we can totally get rid of that first prompt and that first reading in of the two values. And we can just move that into the loop. That was what you were asking, correct? Oh, sorry. Well, I spoke too soon. Please try to repeat what you were going to say then. Yes. Well, then it would not work, because you see it works like this. If the I is greater than the J, if this is true, the code continues after the question mark. So if this is false, the code continues after the colon. So if we reversed it, we could say like this: I is less than J. If that's true, then we would say the second number is larger, or the first number is larger, and then we could try to run it. 10 and 9, the first number is larger, and it will work, but you had to reverse both. So I'll just write in Discord another way to get the correct answer. We'll paste it here. So you see, I just reversed everything. I went from I is greater than J to I is less than J. But very good question. And other questions? What sort of things are on your mind? Okay, so let's continue on with the presentation. The value of the conditional expression is the value of the second expression if the first expression is true, or the value of the third expression if the first expression is false. Parentheses may be needed if you have to deal with the precedence of a conditional operator. And here we see an example. This is a really good one with a consultant. So the consultant charges $50 per hour, but there's a minimum of 5 hours. So if you have a problem they can solve in an hour, they're still charging you $250. Why? Because of their expertise. So we ask the consultant, how many hours did you work? Read it into the hours variable. Now determine the hours to charge for. If the hours are less than the min hours, what do? You set min hours equal to the hours. So if the hours are less than 5, you just set the min hours, which is 5, into hours. So I really like line 20. Line 20 on this slide is a great use of the conditional operator. All right, let's continue on. Now we're on to the switch statement. The switch statement is how we're going to do our menu example. So before I told you, all right, you can use an if, else for a menu example. Most people are going to use a switch statement. So the way the switch statement works is you switch based on an expression that has to evaluate to an integer, and then you have cases that are going to run until you meet the expression. So once we see this running, it'll make more sense. Here we ask the user, enter A, B, or C. So you read it in with CN. You switch based on the choice. So look at the syntax here. We say switch, all lowercase, then parentheses. Inside the parentheses, we have an int variable. And now we're going to have some cases. Case A, you entered A. Notice the break. This is why doing those while examples with the break was not a bad idea. That was a good suggestion, because now we're seeing break where we switch, right? Then we have case B, where we print out you entered B and then we break. Case C, you entered C and then we break. And then we have the default, you did not enter A, B, or C. So let's go ahead and make our first switch statement. So we'll go back to replet, and we'll make a new REPL, and we'll call it switch example C++. All right, so before we worked with students, why don't we say that we are, I don't know, think of an example that you could write a menu program for. Somebody think of a menu-driven program that we can have some different prompts that might be kind of interesting. What was that?
Professor, what
Yes.
about the fast food places?
What about what?
Fast food restaurants.
Hey, I love it. A fast food restaurant. Yeah, that's great. Let's do that. So a perfect example. Let's say, welcome to, I don't know, what would be a funny name? How about we'll just call it the Greasy Spot or something. I don't know. All right, so now we've got our restaurant name that we're putting in the prompt, in the first line. And then we're going to give them different choices, like what they can order. So this is going to be a program that just sits there, and they've replaced their cashiers with this program. So A, to order fries. Well, let's do the letters associated with like the actual names, right? So F, to order fries. And then we have S, to order a shake. And
How
H,
about H for hamburgers?
I love it. H, to order hamburger. So now we have three basic things at a fast food restaurant. And, you know, we don't want to make this example go on and on and on. We'll be sitting here 2 o'clock, 3 o'clock. So this is a good basic 3 prompts. So we can go ahead and make some string variables for the prompts. So we can say std string, and then we'll just say here fry order equals, enter F to order fries. And then we'll have string for shake order, enter S to order a shake. And then we'll have string hamburger order, enter H to order a hamburger. And right now we're just letting them order one at a time. We're not even like worried about quantity. So why don't we have some different prices for these different things? Okay, so we can have const double price of fry equals $1.99. And then we can have price of a shake equals $3.99. And then price of a hamburger equals $3.99 also. Okay. So those are pretty reasonable prices. Maybe low, who knows? All right, so now what we're going to do is we are going to put this into a while loop so they can keep going again and again and again. So why don't we also give them the ability to quit? So Q to quit. So let's say string quit prompt equals enter Q to quit. Okay, so now we're going to have while, and this time we'll just use the break true. All right, so now let's go ahead and...
Professor, you forgot to put the CN for everything.
Yeah, exactly. Now that's a good point. We have to put the cin. Use cin and read this into a variable. Okay, so let's go ahead and let's make a cin right in here and store it into the user choice. So we can say user choice is a character, and we can just get it from cin.get. So this is one way that just we can read a character in one line. So now we're going to use a switch. Okay, the switch is going to be, you know what we can do? We can return 0 directly from the switch. That'll be fun. That way we can just get some practice just ending everything. Okay, so we're going to switch based on the user choice. But you know what? We want to give the prompts. So we're going to go ahead and we're going to print out all these fry order, shake order, and hamburger order inside this loop. So we can say std cout, fry order, shake order, hamburger order, and quit prompt. Okay, so what's the purpose of writing our prompts as strings? Well, if we need to use them more than once, that might make sense. Instead of just typing them in as literals, we can just print them out as the variable names, right? So now we have to use our cases that we talked about before. We can say case F. Now we know the user wants to purchase fries, right? So we have the price of the fries, but we need some sort of variable to keep track of the quantity. Or forget quantity, let's just have total order. So we'll have double total order equals 0. So if we're inside case F, we're going to say total order plus equals, and someone's got the fries there, I like it, plus equals price fry. And we can have a little output. We can say fries ordered. And then we can break out of this. All right, so that's one case. And another case might be case S, which is going to be total order plus equals price of the shake. And then we'll have a printout that says shake ordered. And we'll just type this as a literal. Then we'll say break. And then we're going to have case H. So I think we made 3 things. So now we're going to say total order plus equals price hamburger. And then we'll print out hamburger ordered. And we'll just keep the periods. Okay, and then we'll break. And if they say case Q, then we can say here return 0. Just end the entire program. Like they don't even want to run anymore. And maybe you could, before this, save data to a file, something like that, just to keep track of everything that just happened. Now, what if they don't type any of those? They don't type F, S, H. Well, then we want a default. And the default could be something like std cout, enter a incorrect prompt, incorrect entry, because people don't want to hear prompt, incorrect entry. So now let's go ahead, and I don't think we need a break on that. Now we can go ahead and run this and see how it works. So let's see.
I'm very excited to see how this works.
Yeah, I hope it works on the first try. But you know what? Before we quit, I thought of a good thing we can do. Instead of saving the data, what we can do is we can print out the total order. I like that better. So we'll say your total order is, and then we're just going to put the $sign and then put total order. All right, so let's give this a run, see it if it works. So we say, welcome to the greasy spot, and look at my first mistake. So it's not perfect at all because I put the reading in before I put the prompt. So got to fix that. So let's move the prompt first and then try to rerun it. Okay, so we see enter F to order fries. We say F, fries ordered. Uh-oh, look at the problem. Look at the problem. So it's not
Looks
working.
like we're going to have to do a lot of debugging.
Yep, we got to do debugging. And the truth is, I didn't do this as any sort of like it's just an accident, right? So we see here that after I enter in the F, what could it be? I think I know what it is. I think it's the enter. So I have to say stdcin dot ignore. And this is actually really going to help you when you are doing your assignment on Memer, because the enter, I'm just going to write it out here in comments. The enter was in the buffer and it went into the user choice, the next run through. Okay, so let's try again to rerun it. This is how you test and debug your program. There's no way around it. So we see, welcome to the greasy spot. Okay, let's try to order fries again. Okay, now we're doing good. Fries ordered. Now let's order a shake, and we'll order a hamburger, and we'll quit. Okay, your total order is $9.97. So does that look about right? $2 plus $4 is $6. $6 plus $4 more is $10. 10 minus 3 cents, yes, $9.97, that's correct. So, I mean, I didn't think the math would be wrong, but, if you're being really, really detail-oriented, now we can see this is the switch example, and this is what the code looks like. And I think it's beneficial when it doesn't work on the first try, because you can see how I approach when things go wrong. You can see, okay, this didn't work. How do we fix it? Question.
So much debugging.
Yes, that should be listed on the name of the course. So much debugging, because things are going to go wrong, and you just have to find out where they went wrong, why they went wrong, and there's no way around it. You just have to spend some time with the code and work through those problems. All right, well, let's now think of a problem for you guys to do, because I've been doing most of the talking and typing, but it's good for you guys to do some typing and programming. Okay, so yeah, I would agree with that. Like, I can debug it pretty quickly. I've been doing this for a little while. I think that you guys will get faster and faster, and some of you might spend quite a few hours on these Memer projects.
Some of us are new still at this.
You still what?
Some of us are still new to this program.
Of course. I mean, don't get me wrong. Like part of the reason why I try to debug it quickly is just, in the interest of time. But no, I would not expect anybody, if somebody is programming this as quickly as I am right now in their programming career. I mean, it is possible, because some people just take to it like insanely quickly, but that's really rare. I mean, I've seen lots and lots of students. I've seen a handful who like very early on. They're like the Michael Jordan of programming, right? They're like, they're just so good. But that's super rare. Most people put in tons and tons of time debugging. I was like that as a student. I needed hours and hours. I mean, please, so many hours to read through books, do examples. I don't consider myself like any great programmer, right? Like I make mistakes all the time. Everybody makes mistakes, but it takes lots and lots of time to learn how to do this, to debug things, to get good at it. So yeah, no, don't feel like there's any sort of like rush for you to be typing out these programs in 5 minutes now. So let's go ahead and let's think of a new example. So let's do a instead of a restaurant, why don't we do a pet groomer? So let's go to Replit and let's make a pet groomer. And I got to spell groomer right. And let's say that they have some different options. So the different options for the groomer are going to be groom a small dog for $50. Groom
Professor, will you post the instructions into the Discord?
for sure. Groom a large dog for $70. And I don't know, what's one more thing they could do? They could groom a cat. Yeah, a cat. They're gonna
That's going to be very difficult.
that is going to be difficult, but they're going to have to get paid for it. They're going to have to groom the cat for 110. So here's what I want you to do. I want you to
I'm
ask.
probably going to include the medical bills that the cat gives them. From the cat.
Exactly. They have to charge more for the inevitable medical bills. So ask the user what they need to groom and tell the user the price. So you don't have to do it in a loop for what they want to groom. And we're going to say, don't use a loop. Don't worry about the loop, but use a switch statement. That's important. You got to use the switch statement for this. Okay, so here are the instructions. Let's copy these comments in here and let's paste it in here. And then I see a question in here. It says, can we review my switch example? I keep getting in it. Yeah, of course. Before you start on this one, paste your code. So either post a link to your Replit. Perfect. Great. And let's do this. All right. So we see here that this student says, welcome to the greasy spot. Okay. Enter F to order fries, enter S to order shake, enter H to order hamburger, all good. Enter Q to quit. Now we've got the prices, total order, and okay, so yeah, I think the missing step is just the STD. It's the STD CN.ignore. So I think this is the missing step. And no, it's still not working. Okay, so we have fry order, shake order. Oh, okay. So it looks like, what is the problem here? STD, fry order, shake order. So it's on line 15. It's, what's the problem? Fry order, shake order, burg order. Yeah, no, this is a hard thing to figure out. So you got fry order, shake order, quit prompt. Wow, this is really. So I said people complimented me before on quick debugging, and now look, I don't know what's the problem. So if somebody else sees the problem, speak up. Let me see. So it says undeclared identifier Berg order, but here you did define Berg order. Wow, what is this? What is this? See out. Okay, you got price fry, price shake. So let's see here. Quit fry order, shake order. Just out of curiosity, let's just try to print one thing. So we'll say see out fry order and try to run it. Okay, it's. Am I sure that Berg order was defined? Well, I mean, this. Oh, wait. Berg order. This is where you define it. Is there a spelling issue? Let's see. Copy this. I mean, I can copy and paste everything. I mean, maybe something was misspelled, but oops. All right, quit prompt. All right, let's see. Use of undeclared identifier Berg order. I'll just call it burger. STD string burger. Go in here, burger. So you've got C out going this. Yeah, that makes sense because C out goes that direction. Okay. Yeah, they don't like. Let's take it step by step until we figure it out. So we'll say C out, and then we'll go here to fry order. Then we can see out shake order. Then we can see out burger. And then we can see out the prompt. Wait, no, it was called quit, right? I see people commenting. Quit prompt. And let's see which is the problem here. I did it. Use of undeclared identifier burger. So what's the problem here? So we go here, std string b equals enter h to order burger, order hamburger. Okay, so then we'll just put in here b. Okay, so what's the problem here? Enter. This goes with this. Yeah, but why? What's the problem? Enter H to order hamburger. I mean, this is just the weirdest thing. If you remove the hamburger, it works. It just doesn't make any sense. All right, so we removed the hamburger. Yeah, this is just the weirdest bug. I mean, I don't get it. So let me try to make it again. So we'll say here std string hamburger equals enter h to order hamburger. And then we go down here and we're just going to print out std cout hamburger. Okay, let's run it. Okay, now it works. So, yeah, that's weird. That was the weirdest thing. So it looks like the way I solved it was just erase the hamburger and then just rewrite it. Have no idea why the hamburger wasn't working before. But if someone wants to like review the video or send it to Stack Overflow, maybe somebody out there will find out what I was missing. I don't know. It's just weird. One of those weird. Yes.
Might I add that the first two lines, like line 18 and 19, should go before the switch instead of like right there, because you see how the props don't open up.
Yeah. That's really true. I was so worried about the hamburger, I didn't even think about that.
No, I thought that was a problem, right? So I switched it around, but it still gave me the same error with the hamburger. I don't know why.
Yeah, that was a weird error. So that's a good point. We do need to move these prompts beneath we need to move the reading in beneath the prompts. And there we go. So let's go ahead and copy this, then paste it here. Oh, you think you figured it out? The backslash in the comment? Yeah, copy and paste the string that you which right. But what was the initial thing? Like copy and paste the initial string. That does make sense. A backslash would ruin things. And I totally missed that. Okay. Yeah, perfect. Yeah, and that explains it all. So you don't have to submit the video to Stack Overflow anymore. We figured it out. So perfect. Good. All right, cool. So no problem. I think that was, again, good use of time. So let's go back to our pet groomer example. So let's just press back a few times. And let's copy and paste this into here. I had a slash confusion on quiz 2 with backslash n and /n. So yeah, the backslash n is how you make a new line. So the backslash is a special character, and I really, my debugging skills were lacking there because, you know, if you have that inside of a string, it's going to lead to trouble. So yeah, that's the important thing. Yeah, and sometimes they can be hard to see, and like, you know, I'm not going to beat myself up over it. You know, like sometimes it takes a little longer to debug things than others, and that's okay. Yes, imagine doing that in a much larger program. You know, the truth is you can get stuck on little things, and sometimes you're sitting there, you're looking at it, and you just takes a while, you know. But you know, then you figure it out, and then you move on. You fix the next bug. Okay, so let's all try to do this switch statement program. Now, let's give enough time a chance to do this. So let's all say at least 10 minutes, even more than 10 minutes. At 12:15, let's all show our code. And yes, I'll probably make this count for attendance. So everybody, let's try to do this. Now, if you're really fast and you get it done, don't share it immediately, but you can just start working on your memer assignment. So it's not like this time will just be wasted and you have to just sit there looking at an empty screen. So if you finish early, work on your memer assignment, which is called making decisions. And then if you finish that, then you even have quiz 3 that you can do. So there's lots to do. I don't like for students just to feel like they're wasting time, but let's all try to do the switch statement. And then if you make mistakes, I can work with you for the remainder of time and show you how to fix it. Okay, let's all do it. All right, great to see people posting. So what I'll do is I'll just run them, and I think you really only need to stick around if something doesn't work. So we see here this looks good. Yes, perfect. And then I'm just going to put a thumbs up once I look it over, and then give you your attendance. So if you go ahead and see the thumbs up, then you're good to go. And I'll see you next time. So since it doesn't seem to be any more questions, I guess you can go ahead and stop the recording, because they'll be pretty like individual questions.